So in this topic, we are going to discuss about the adsorbents that are being used in the adsorption process for the dehydration of natural gas. So we have four different adsorbents, that is alumina and gel and the molecular sieve. Just look about the brief about all these three one. So number one is the alumina. So alumina is the hydrated form of aluminum oxide. Alumina is the least expensive adsorbent, that is a very cheap and very good one. It is activated by drying off some of the water associated with it in the hydrated form. So what happened? Normally it is in the equilibrium in a stable form in alumina with the hydration of 3 molecule of the water. But if you provide the heat to this hydrated form of alumina, it will be dehydrated, and if there is dehydration, then always alumina is ready to absorb the water. That is the basic thing. It produces an excellent dew point depression up to the minus 100 degree Fahrenheit, but that require the more heat for the regeneration. So although that is a very good for the very low dew point depressions, but the heat of regeneration is very high in that case. So it is alkaline and cannot be used in the presence of acid gases or the acidic chemicals that are being used sometimes in the well treating. So what happened, that will be a part of this water, and that can create a problem because of the alkaline nature of the alumina. The tendency to absorb the heavy hydrocarbons is very high with the alumina, and it is difficult to remove these during the regeneration. So that's why the heavy hydrocarbons are not very much good for the alumina. If there are very high concentration of heavy hydrocarbons in a natural gas, then there is a problem. It is a good resistance to liquids, but little resistance to disintegration due to the mechanical agitation by flowing gas. So continuously there is continuous mechanical agitation because of the flowing gas. So disintegration is going on because of the this flowing gas. So this is all about the alumina. Now come to the gels. There are two types of the gel. One is the silica gel and the second is the silica and alumina gel. So gels are the granular amorphous solids manufactured by the chemical reactions. So gel are manufactured from the sulfuric acid and sodium silicate reaction that are called the silica gels, and they consist almost solely of the silicon dioxide, that is SiO2. So basic cheese is the SiO2, that is the silica. So alumina gels consist primarily of some hydrated form of the alumina Al2O3. So silica alumina gels are the combination of the silica gel and alumina gel. So what happened, these gels can be dehydrate the gas up to as low as the 10 ppm and have the greatest ease in the regeneration of all the sequence. That is a very good thing, because in the regenerations low heat as compared to the simple alumina is required here. They absorb the heavy hydrocarbons but releases them very relatively more easier as compared to the earlier case during the regeneration process. So that is one of the very important thing. So although they absorb, but they have the very low heat requirement for the regeneration. Since they are the acidic in nature, they can handle the sour gases. There is the acid gas also, but not alkaline materials such as the caustic and ammonia. So if the ammonia and caustic are present in the natural gas, then there will be a problem with the gels. Although there is no reaction with the H2S, sulfur can deposit and block their surfaces. So this is one of the problem that has been observed with the gels, that the sulfur formed available in the natural gas, they can be blocked and they can deposit on the surfaces and they can deactivate the portion of the solid desiccant. Therefore the gels are very useful if the H2S content or the concentration is less than 5 to 6%. So that's why we are not very much this material gel are not very much good for the sulfur concentrations. The third one, we are discussing about the molecular sieves. So they are the crystalline form of the alkali metals or the calcium or sodium metals, aluminosilicates, and they are very much natural, very much similar to the natural clay. So they are very highly porous. They have a very high active area with surface area, basically a very narrow range of pore sizes, and because of this they have a very high surface area. Molecular sieve are the most expensive adsorbents as compared to the other one. They possess a highly localized polar charges on their surfaces that act as extremely effective adsorption sites for the polar compounds such as the water and hydrogen sulfides. So that's the basic mechanism in the molecular sieves, how they are absorbing the water and the hydrogen sulfides and some other polar compounds available in the natural gas. And the molecular sieves are alkaline in nature and subject to the attack of acids. The special acid resistant sieves are available for the sour gases, and Since the pore size range is very narrow, so the molecular sieves exhibits the selectively towards the adsorbents on the basis of their molecular size. Means we can maintain the different type of the molecules, we can control the molecules up to the because of these narrow sizes, and tend not to absorb the bigger molecules such as the heavy hydrocarbons. So that is the one of the advantage in the molecular sieves. Sieves are subject to contamination by carryover of liquids such as oil and glycols. So they are the available. The temperature for the regeneration is very high here, and but they can produce the water content as low as 1 ppm. So it is a very much effective molecular sieves. Molecular sieves offer one of the advantages, offer the simultaneous dehydration and desulfurations both, and therefore a very good choice for the sour gases. They can even reduce the concentration of the H2S, H2S also. So while going for the dehydration process, in fact a partial desulfurization is also going on in the molecular sieves. So overall molecular sieves is very good one. It can lower the temperature water up to the 1 ppm, but it is a very costly, and obviously there are some other problems like it requires more heat for regeneration. So this is all about the different types of the available adsorbents. Thank you very much.